Chapter 3, Lesson 5 of Pre-Calculus, and I wanted to do one final video where I looked at some logarithmic equations that might be considered difficult, or a little bit more difficult than what we've been used to working with. And there are a couple of things that I want you to note when we do this. Those things that I want you to note will be covered in the first example, so if you think you have it after the first example, then you can obviously stop watching that. After that, if you want some more help, then I'm going to do a total of 5 examples in this video, so you can watch as many as you need. We're going to take a look at this first equation, and we're asked to solve it. And again, I notice it's a natural log, and I notice I have multiple logarithms, so I'm going to need to use my properties of logarithms to get that down to a single logarithm and then change it to exponential. So let's do that first. So it's a natural log, and then I have the value x minus 6, and then a minus sign, you remember, means divided by, and then we have the next value, x minus 1, and that is equal to 2. Now we have our single logarithm, so now we want to do the inverse function, and that is the exponential. So we want to change this logarithmic equation into an exponential equation. Now in recent videos, this base e and this exponent over here was a 0, which always gave us a 1, because e to the anything to the 0 power, is 1. And so it made things kind of easy. This is going to make things just a little bit difficult, but just we have to remember some algebra skills, that's all. And so we have base e here. So we have e. What's the exponent of e? Well, the exponent of e is 2. It's over here. That will produce this value here of x minus 6 over x minus 1. Now that we have this, again, we don't want to change this into its decimal form here because it's an irrational number, and we don't want to use decimal approximates if we're going to continue to do some calculations. So we'll just leave that e squared. Now to solve this equation, we want to multiply both sides by x minus 1 in order for that denominator to go away. So we're going to have x squared times the quantity x minus 1 is equal to x minus 6. Now remember, we've talked about there's two things that we always do when we're solving an equation, or kind of two overriding things that we want to do when we're trying to determine the value of a variable. We want to get that one variable all by itself on one side and then undo that last operation. We're solving for x here, and you'll notice there's an x on both sides of the expression, so I'm going to need to get those x's on one side so that I can combine them as like terms and then do that last step, or that inverse operation. So I'm going to need to distribute this first. So this is going to be e squared x minus e squared then is equal to x minus 6. Now again, here's my x term and here's my x term, so I'm going to move this term to the other side in order to get the x's together, and I'm going to move this term to this side so that because it does not contain an x, and then I'll have just x's. So this is going to give me then negative e squared plus 6 equals x minus e squared x. Okay, so now I have both terms with x's isolated over here, but now I have a problem in that while they're like terms, this is a 1. How do I add that to e squared? And we really don't want to change it to its decimal approximate here, so how can we do that? Well, if you think about these two terms, they have a common factor of x, so actually I can factor x out. And so that's going to give me negative e squared plus 6 is equal to, and then if I factor the x out, that's going to be 1 minus e squared. Okay, now that I have x times this, I have the x term isolated, I undo that last operation, so I'm going to divide by 1 minus e squared. So x is going to be equal to this negative e squared plus 6 divided by 1 minus e squared. Okay, now this is my exact answer. Okay, now there's something interesting that happens here, something we have to be aware of. I have to actually change this to its decimal form now to make sure that I don't have any restrictions, and I'll show you what I mean in just a moment. So if I take this number, then e squared, whoops, I'm going to do this, e squared, I'm sorry, I got to get this right, it's negative e squared, all right, and then I push enter. Whoops, I'll get it. Enter, and then I'm going to add the 6, enter. That gives me the numerator. And then I'm going to divide that by, I'm going to use parentheses here to make sure this 1 minus e squared is the denominator, equals, I get a 0.2174. Okay, so this is 0.2174 approximately. That's the decimal approximation. Now, you'll notice that that's my x value. Now, if I put that x value in here, 0.27 or 2174, what happens? If I subtract this, this ends up being a negative value. And you'll notice if I put it in here, this also is a negative value. Now that's a problem, because you remember when we began our discussion of logarithms, one of the restrictions was that this value here can never be a negative value, because we're taking a positive e, that's the base, and we're raising it to a positive power. How can we get a negative number? Well, we can't. So this equation actually then has no solution. And it has no solution because the value that I use does not produce a positive value here, and this must be positive. So you have to remember that when you're doing these logarithmic equations, especially solving for x, that you can have a situation where there's no solution if the solution you arrived at correctly and algebraically, if you substitute it back into the original equation, if it produces what do you call them, restrictions, or produces mathematical impossibilities, undefined, that's the word I was looking for. If it produces something that's undefined, then there is no solution to the expression. Alright, so make sure with these that you check for that, and then again, this little factoring out the x to kind of help you solve for x and not using approximates should help you. Alright, so again, I'm going to do 4 more examples. You can watch as many as you want, and hopefully they'll be helpful to you moving forward. Actually, for these next few, I'm going to move down here and have the answers ahead of time. So again, as I look here, I'm going to solve this. I know there's no solution. I know that. So again, I'm just going to have to check my work at the end and see why there's no solution. So I have 2 values here. So I'm going to get them down to a single one. Minus means divided by. So I'm going to divide by this value equals 3. I have my single logarithmic. I'm going to change it to exponential. So I have a base e to the 3rd power produces this value of x minus 1 over x plus 2. I'm going to kind of go this way, save some room. I need to multiply both sides by x plus 2 in order to remove that denominator. And then I'm going to distribute the x. No, I'm going to distribute the e cubed. Equals x minus 1. Now again, I have x over here and x over here. I need those together in order to solve. So I'm going to isolate. So this is going to be x minus e cubed x. Alright? Now I have the x's, but again, this irrational number with this number I can't really add, and so I'm going to factor out the x, leaving me 1 minus e cubed. And now this is x times this, so I can undo that by doing the inverse operation, or dividing by 1 minus e cubed. That's my x. So that would be my value, but I have to again check and make sure I don't produce a negative value, because this is a minus 1, so I need a number bigger than 1 if this is going to work. So I'm going to take 2e, and then that's going to be, whoops, I'm having trouble with my calculator today. 2e, no, it's never the calculator, it's always the operator, plus 1 equals, alright? So then divided by, and then 1 minus e cubed, and that's going to give me negative 2.157. So now it's a negative number. So if I put that negative number, this negative 2 in here, minus 1, this is going to be natural log of negative 3, which again is an impossibility. So again, this is a no solution problem, because the solution that I get algebraically does not make the original equation true. All right. So I'm going to do a couple more, and again, just if you kind of want to scroll ahead, those are the only two no solutions. The next two will, or the next one will have solutions. So you can kind of watch and see if you get the same thing I do if you need. But remember, we do have to check those. All right. Matter of fact, I just thought of something, but I'm going to keep it to myself. Sorry. I thought I might share something, but not. Okay. Two logarithms, need to get it to 1, so natural log, and then I have x plus 5, and then I have a minus, so again it's divided by, and then I have the value x plus 4 is equal to 1. Now it's a single logarithm, so change it to exponential, so the base e raised to this power produces this value here. We're going to multiply both sides by x plus 4 in order to eliminate that fraction, or remove it, so to speak. We're going to distribute e. Oops, I wrote x there. That's not an x, that's an e. That's e times x, not e to the x. Okay, plus 4e is equal to x plus 5. I need to get these x values together on one side, so I'm going to move this to the other side. So that's going to be 4e, and I'll need to move the 5 over to this side. X minus e, x. I'm going to factor out the x. That's an equal sign. Yeah, I better go back and change that. Equal, and then factor out the x. So that's 1 minus e. And then I can divide by 1 minus e. So to put it in the form they do have here, just so we can see, I do have a negative 5 plus 4e, and then I'm going to divide by 1 minus e equals x. Whoops. Having trouble making my equal signs not cross over. I'll have to slow down. Okay, so that would be the value. And again, I know the answer, but what I would need to do then is I would need to calculate that and make sure that when I substitute that value back into these, I do not get a negative value. Okay? All right, we'll do 2 more. Do number 4 over here, and then we'll do the last one. All right, so again, 2 logarithms, so I'll need to combine those. So 5 minus means divided by. So this value here equals 1. Then I'm going to take the exponential, or change it to exponential form. So e again to the first power produces this 5 over 2x plus 2. We'll multiply both sides by 2x plus 2 in order to remove it from the denominator. We'll distribute. Now let's do this. 2ex plus 2e is equal to 5. And then I already have this ex term, that's fine, so I just need to move the e. So 5 minus 2e. Now I'm solving for x, so I'm going to divide by 2e. 2's reduced and the e's reduced. So divide by 2e. So this is x equals 5 minus 2e over 2e. Now notice they stopped here. This is the exact answer. Remember, you cannot simplify these because of this minus sign. However, if you felt the urge like you wanted to simplify those, you could make this just a little bit different. If I remember, well, 5 is over 2e, which is correct, and then I have minus 2e over 2e. Remember, that's what that fraction means. Now this reduces this, leaving 1, so a different form of the answer could be 5 over 2e minus 1. Either one of these would be correct. I saw the answer ahead of time, so I'll leave it like this because that's what they did. But you can see there is a different version of that, or a different form of that if you want it. All right, I'll do one more example, and hopefully that's been helpful to you. And I think I have one more example. Why does that keep coming back? I'd have one more example. Let's do that. Let's try to move this up. Oh, yes, there we go. One last example. Okay. All right, 2 logarithms. So again, we're going to change it into 1. So I have 2. Now this time plus means multiply. So I'm going to multiply 3x plus 7 is equal to 5. I have my single logarithm, so I'll change it to exponential. So e to the 5th produces this 2 times 3x plus 7. We'll then distribute. Oh, because I need to get the x. So this is 6x 14. Then I'll subtract the 14 to get that term with the x in it by itself, and then I'll divide. So e to the 5th minus 14 over 6 will be my x value. And again, I have the answer here, but again, I would want to check that by determining what this is from a decimal equivalent standpoint and make sure that when I substitute it in, I don't get a negative value. Okay? All right, so those would be the more difficult ones. Hopefully that was helpful for you, and that will wrap this lesson up with solving logarithmic expressions, or equations, excuse me, solving logarithmic equations.